Intro Algebra Lesson 2-3A. We've spent time now adding positive and negative numbers. And we're going to move from adding positive and negative numbers into subtracting positive and negative numbers. But in reality, what I'm going to show you today is a way to change the appearance of those problems so that you can go back to your old addition rules and hopefully make fewer mistakes. I find that subtraction, especially when you're dealing with positive and negative numbers, leads students to a number of accidents. They're not intentional, obviously. Maybe speed has something to do with it. They're going too fast. But whatever it is, students make more mistakes dealing with subtraction of positive and negative numbers than they make with addition in positive and negative numbers. So I would encourage you to try as much as you can maybe to revert or convert problems into scenarios that are easier for you to deal with, which is addition. So our first bit of info here talks about subtraction, and there's a rule on page 79. It's a little bit confusing, that rule, so don't get too caught up in that rule itself. This is really the concept that I want you to kind of get the hold of. And it may not make sense at first, especially reading it up here, add the opposite doesn't necessarily make sense. But what I'm telling you is you can change any subtraction problem into addition. Now you might say, what? How can you just change a subtraction sign into addition? Well, it's pretty easy. I would take the subtraction sign and just draw a line through it and it looks like add. The problem is you can't just leave it that way because then that would mean that subtraction and addition were the same. You can only change subtraction to addition if you're willing to take the number that directly follows that sign and make it its opposite. So what I'm saying is if it was -7, you would need to change that subtraction to addition, but that 7 now would have to become a -7. You change it to plus, the opposite of whatever number follows. That's the concept. And if you can change it to addition, then you're right back into your same addition rules. Negatives plus negatives make more negatives. Positives plus positives make more positives. And if you have a positive and a negative, you ask yourself, which do I have more of? All right? So here's what I'm saying. 5 minus 3. Make it add the opposite. Right now, this is subtract a positive 3. What I'm trying to suggest is change this subtraction to addition and change it from a positive 3 to a -3. If you do that, it'll give you the exact answer, the same answer. We know that 5 minus 3 is 2. And if I saw 5 plus a -3, I'd ask myself, which do I have more of and how many more? The answer would be 2 more positives. So we know it produces the same answer. I'm trying to get you to focus on the fact that that has changed to addition, and this, which was a positive 3, is now a -3. That's what I'm trying to get you to grasp. Change that sign each time. All right? Here's another situation. This is the type that people really make mistakes with. People don't generally mess up on 5 minus 3 so much, although there could be some other scenarios. It's the 6 minus a -4. People take 6 minus -4 and they go, oh, that's 2, or -2, because they take 6 and they subtract 4. But what I want you to see is this subtraction has now become an addition sign. And this -4 is no longer negative, but a positive 4. And I think that we are far more likely to do 6 plus 4 correctly and get 10 than we are to go 6 minus -4 and accidentally get 2 or -2. The reason why this stuff works, and I'll demo it here with a quick number line. Say your middle is here where 0 is. Anytime that you add positive numbers, if you add positives, the number is going to move this direction. A little lag there again. Adding positive values moves the number to the right on the number line. If you add 2, you move 2 places to the right. Now, that doesn't mean that's the only thing happening here. If adding a positive takes you to the right, then adding or subtracting a positive can't go the same direction. Subtracting positive has to go the opposite direction. Subtraction and addition are opposites. Positive is the same. The subtraction of positive has to go the opposite direction of adding a positive. All right, good. Now, over here, if subtracting a positive makes you go left, what would subtracting a negative do? Subtracting a negative can't go the same direction as subtracting a positive. which means subtracting a negative is actually the exact same thing as adding a positive. Oh. Subtracting a negative was the same as adding a positive. Same direction on the number line. If adding a positive takes you to the right, then adding a negative can't go the same direction. Adding a negative must go this direction, to the left. Which means adding a negative is the same as subtracting a positive. That's what we had up here. Subtracting a positive was the same as adding a negative. I just think you're less likely to make mistakes when you add values than when you have subtraction. Not to say this is a hard problem, but there could be some later on that are more difficult, and we're less likely to make mistakes when it's addition. So I just caution everybody about that. Be careful of it. Alright, let's try some out. We're just going to get ourselves in the habit of changing it to plus the opposite. So if you saw 4 minus 6, you would change that to plus the opposite. And 4 plus negative 6 would then be negative 2, because you have 2 more negatives than you do positives. Alright, more of the habit. Change that to addition means the sign that follows has to change. You will be making 2 changes every time. You'll make 1 change to the subtraction, you'll make a 2nd change to the value that follows. 8 plus 9 is now 17. When it was 8 minus negative 9, people get all kinds of answers like negative 1 and 1. You got to be really careful with those signs. 7 minus negative 2 plus positive. 7 plus 2 now equals 9. Again, I make 2 changes every single time. 11 minus 3, yeah, I know you can do 11 minus 3 and get 8, but practice plus the opposite. You have how many more positives than negatives? You have 8 more positives. It still works, but all you have to do is deal with the addition. 12 minus 39 plus negative. I have a lot more negatives than I do positives. In fact, I have 27 more negatives. So negative 27 is, negative 39 is 27 more negatives than 12. If you add 12 and 27, you get 39, so I know that's why it works. And the last of these little quick ones, remember again, if you want to change it to addition, the sign that follows has to change. 13 plus 67 now equals 80. Much less likely to make mistakes. If you recall, we had special properties for addition that allowed us to multiply or add in any order we wanted. Changing problems to addition will give us more of that freedom. Alright? So, find the difference. Again, if I want to make this addition, that's got to become positive. 9 plus 8, 17. Alright? Uh-oh, it's got decimals in it. This is a big place. People make the up-down subtraction. You got to be careful. What I would suggest, plus positive. You're adding a negative and positive, so you're supposed to ask yourself, do I have more negatives or more positives? We have more positives, so we know the answer is positive. Put whatever you have more of on top and subtract what you have less of. Be very careful that you don't do up-down subtraction. People accidentally go 6 minus 4 is 2 and 6 minus 2 is 4, and they end up with 2.4, and that's the wrong answer. Borrow. 12 minus 6 is 6, decimal straight down. 5 minus 4 is 1. I had more positives than negatives, so it's 1.6. It still works even with decimals. Alright, 7.8 minus 13.5. Make the change. Plus negative. This time we have more negatives, so I know the answer is negative. Put what you have more of on top and subtract what you have less of. Again, be watchful of the up-down subtraction. Don't go 8 minus 5 up is 3 and 13 minus 7 is 6. Happens all the time. Borrow. 15 minus 8 is 7. Decimal straight down. 2 minus 7? No. Make that a 12. 12 minus 7 is 5. So we have negative 5.7. The biggest mistake is people get 6.3 and then it's off. Alright? Again, fractions. That's okay. Plus the opposite. When you add fractions, you keep the same denominator and the tops add together. So 3 plus 9 is now 12 over 5. There's nothing wrong with leaving it as an improper fraction. You can convert it into a mixed number if you like, but you don't have to. If you did, that would be 2 and 2/5. But again, plus the opposite. If you change it to subtraction to addition, you must change the sign that follows. Okay? Plus negative. Negatives plus negatives makes more negatives. So we end up with negative 8 over 8, which is negative 1. Be keep the same denominator. Big mistake is people add those and get 16. Alright? 14 minus negative 3. We do not want to go plus positive here, because this is actually an absolute value. We must take care of absolute value first. So what's the absolute value of negative 3? It's positive 3. Now, you can do 14 minus 3, but if we practice what we've been doing, it becomes plus negative, and there are 11 more positives than the negatives. Big mistake is people go plus positive. 14 plus 3 is 17, and they end up with the wrong answer. Do the absolute value first, then change your subtraction to plus the opposite. All right, another scenario where we have that. Don't make this plus negative. That's not what we want. We're going to do the absolute value first. The absolute value of 7 is 7. So it's negative 4 minus 7, which will then make plus negative. Negatives plus negatives makes more negatives. And one final example, a lot of problems. Okay, that's all right. More than one number. Same thing. Plus positive, plus negative. Now it's addition. You can add in any order you want. Might as well put the positives together. 2 plus 5 is 7. 7 plus a negative 8. You have one more negative than you do positive. So the answer is negative 1. Changing from subtraction to plus the opposite gives us freedom, and it decreases the chances of some of the mistakes that are typically made with subtracting positive and negative numbers.